Have you ever imagined a huge place that has all the knowledge that ever was and ever will be? Think of the largest library you can picture, but make it even bigger. This is the idea of the Library of Babel, an idea put forward by an Argentine writer named Jorge Luis Borges. Now, this is not your typical library. It's shaped like a honeycomb, with book-filled hexagonal rooms connecting to each other. But here's the interesting part: it doesn't just have all the books that are already written. This library also every book that could possibly be written. It has possible combinations of words and sentences in a book of 410 pages. That means it has everything, from the deepest philosophical thoughts to simple everyday stories, from fairy tales to factual accounts. Every possible story is already in this infinite library. And that's mind-boggling. It suggests that there's a book somewhere in this massive library that could tell the future perfectly, a book that has the solution to all diseases, and even a book that narrates your entire life in detail. But there are also countless books that don't make any sense at all, with random combinations of letters. Among all these meaningless books will be valuable and sensible ones. But there's a twist: finding a specific, meaningful book in this sea of information almost impossible. It's like looking for a needle in a haystack. That's why the Library of Babel is a paradox. It's a place where searching for knowledge can feel pointless because of overwhelming amount of information. It's a symbol for the universe, infinite, full of potential, yet chaotic and seemingly without order. In the Library of Babel, every story, fact, and piece of knowledge is already there. But the real challenge is to find meaning within the chaos, to find that one book among countless others. That's mystery and fascination of the Library of Babel. What if I told you that two particles, no matter how far apart, could affect each other instantaneously? Welcome to the intriguing world of quantum entanglement. Quantum entanglement is a fascinating phenomenon of quantum mechanics that has been known to boggle even the brightest minds. It's a concept where two or more particles become so intimately connected that the state of one particle can instantly influence the state of the other, no matter the distance separating them. Yes, you heard it right. Instantaneously. Now let's try to picture it. Imagine you have two entangled particles, one in New York and the other in London. If you measure the state of the particle in New York, you'll instantaneously know the state of the particle in London. This is not because they are sending signals to each other faster than the speed of light. Rather, they are so deeply intertwined that they behave as a single entity. This idea, as you might have guessed, severely challenges our classical understanding of space and time. According to Einstein's theory of relativity, nothing can travel faster than light. But in the quantum world, entangled particles seem to communicate instantaneously. This led Einstein to famously refer to quantum entanglement as spooky action at a distance. But don't be fooled by the word spooky. Quantum entanglement isn't some paranormal phenomenon. It's a well-studied and experimentally confirmed aspect of quantum mechanics, the theory that describes the smallest particles in our universe. And it's not just a theoretical curiosity either. It has practical applications in areas like quantum computing and cryptography, and may even hold the key to a future of super-fast, ultra-secure communication. So the next time you feel lonely, remember, in the quantum world, everything is deeply interconnected. We are all entangled in this grand cosmic dance, where actions in one corner of the universe can ripple out and affect things far, far away. Quantum entanglement, a concept that turns our understanding of the universe upside down. Can collective memory be flawed? Can groups of people remember events differently than they actually happened? Welcome to the world of the Mandela Effect, a beguiling phenomenon that plays tricks with our memory. It's a strange twist in our reality, where what we recall and what history tells us diverge. The Mandela Effect is named after Nelson Mandela, the anti-apartheid revolutionary and former president of South Africa. It stems from a misremembered fact that bewildered the collective consciousness. There was a widespread belief held by many that Nelson Mandela had died in prison during the 1980s. However, this was not the case. Mandela was released in 1990 and went on to become the president of South Africa, passing away in 2013. This is not an isolated case of flawed memory. The phenomenon extends to various aspects of popular culture, history, and even our everyday lives. It's as if we've slipped into an alternate reality where facts are slightly askew. It's not uncommon to hear of childhood memories of books, cartoons, or movies that don't match the existing versions. These aren't simple cases of forgetfulness or misrecollection. They are shared by a large number of people, often with vivid detail. Some attribute the Mandela Effect to confabulation, where the brain fills in gaps in memory with fabricated, misinterpreted, or distorted information. Others propose wilder theories, such as parallel universes or even manipulation of the space-time continuum. Despite these explanations, the Mandela Effect remains a puzzling curiosity. It challenges our concept of reality and memory, making us question the trustworthiness of our recollections. It's a testament to the fallibility of human memory and a reminder that our perception of the past can be as mutable as the future. As we delve deeper into this mind-bending phenomenon, we are left to ponder on the elasticity of our shared memories and the mysteries of the human mind. The Mandela Effect, a curious phenomenon of collective false memory. What if I told you the most resilient creatures on Earth are microscopic and can survive the harshest conditions imaginable? Enter the world of tardigrades, affectionately known as water bears or moss piglets. These minute animals, typically around 0.5 millimeter in length, inhabit a world unseen by the human eye. Yet their resilience and survival capabilities are nothing short of extraordinary, making them some of the most fascinating creatures on our planet. These tiny marvels are known to survive in environments that would be lethal to most life forms. From the freezing temperatures of the Antarctic to the boiling hot springs of Japan, tardigrades have been found thriving. They can withstand pressures 6 times greater than those found in the deepest ocean trenches and endure radiation levels that would be fatal to humans. But their extraordinary capabilities don't stop there. Tardigrades are also one of the few creatures known to survive in the vacuum of space. Yes, you heard that right. These water-dwelling micro-animals can survive without water in the absolute zero temperatures and cosmic radiation of outer space. How do they achieve these feats of survival? Tardigrades have a unique ability to enter a state of suspended animation, known as cryptobiosis. In this state, their metabolic activity drops to less than 0.01% of normal levels, and they can remain in this dormant state for years, even decades, until conditions become favorable again. But don't let their tough exterior fool you. Tardigrades play a crucial role in our ecosystem. They contribute to the decomposition of a plant material, play a part in the food chain, and help to maintain the health of the environments they inhabit. So next time you take a sip of water or walk through a mossy forest, remember the tardigrades. These tiny creatures, invisible to our eyes, are living proof of the incredible resilience of life. They remind us that in the harshest of environments and against all odds, life finds a way. Tardigrades, tiny creatures showcasing the incredible resilience of life. Can something be both a wave and a particle at the same time? This question may sound like something from a science fiction novel, but it's actually a fundamental query in the field of quantum physics. The answer lies in the Double-Slit Experiment, a testament to the wave-particle duality of electrons and photons. Imagine a wall with 2 slits and behind it a screen. We fire a stream of particles such as electrons or photons at the wall. Classical physics would predict that each particle passes through one slit or the other, creating 2 bands on the screen. But that's not what happens. Instead, an interference pattern of alternating light and dark bands appears on the screen. This pattern, familiar to anyone who has observed ripples in a pond, is characteristic of waves, not particles. So it seems the particles are behaving like waves, but here's where things get even more bizarre. If we decide to observe which slit each particle passes through, the interference pattern disappears. It's as if the particles know they are being watched and revert to behaving like particles. This is not just strange, it's downright mind-boggling. This enigmatic behavior of particles is known as wave-particle duality, a cornerstone of quantum mechanics. It tells us that particles can exhibit properties of both particles and waves, but the moment we try to observe them, they choose a side. The Double-Slit Experiment challenges our intuitive understanding of reality. It suggests that the act of observation can influence the behavior of particles, a concept that shakes the very foundations of classical physics. This experiment is not just a quirky science trivia, it's a gateway into the strange and counterintuitive world of quantum physics. In conclusion, the double-slit experiment is a testament to the fascinating, albeit perplexing, realm of quantum mechanics. It reminds us that at the quantum level, nature dances to a different tune, one that's both mystifying and beautiful. The double-slit experiment, evidence of the strange and counterintuitive world of quantum physics. So, what if most of the universe is made up of something we can't even see? It's a mind-boggling proposition, isn't it? Yet it seems to be the case. It's estimated that around 95% of the universe is made up of dark matter and dark energy, substances that remain elusive and invisible to us. Dark matter is a hypothetical form of matter that doesn't emit or interact with electromagnetic radiation, which means we can't see it, hence the name. Yet we know it's there because of its gravitational effects on visible matter. It's like a cosmic ghost, making its presence known through indirect means. It's the unseen hand that shapes galaxies, bending and warping space-time around it. Then there's dark energy, an even more mysterious entity. It's believed to be the driving force behind the accelerating expansion of the universe. You see, according to Einstein's theory of general relativity, gravity should be pulling everything in the universe together. But that's not what we're observing. The universe is expanding, and at an accelerating rate. This mysterious force pushing the universe apart, that's what we call dark energy. Together, dark matter and dark energy make up the vast majority of the universe, yet we know so little about them. They are the celestial elephants in the room, the cosmic mysteries that keep astrophysicists up at night. We're like explorers on a vast ocean, with only a small lantern to guide our way. We can see a little bit of the water around us, the visible universe, but most of the ocean remains in darkness. That's dark matter and dark energy. The unseen majority of the universe, the invisible forces shaping our cosmic destiny. So the next time you gaze at the night sky, remember this. What you're seeing is just a fraction of the universe. Most of it is made up of something we can't even see. Dark matter and dark energy, the unseen majority of our universe. Could the flap of a butterfly's wings in Brazil cause a tornado in Texas? This intriguing question introduces us to the concept of the butterfly effect, a fascinating principle in the realm of chaos theory. The butterfly effect suggests that small, seemingly insignificant events can set off a chain of reactions leading to massive, far-reaching consequences. This idea was first proposed by meteorologist Edward Lorenz in the mid-20th century. While running weather simulations, Lorenz discovered that tiny changes in initial conditions could dramatically alter the resulting weather patterns. This led him to the profound realization that small variations in a dynamic system like the weather could trigger a domino effect, leading to substantial and unpredictable results in the future. Consider the butterfly in Brazil. Its wings disturb the air around it ever so slightly as it flutters along. These disturbances might cause slight changes in wind patterns, which could in turn influence the formation of clouds. Over time and across vast distances, these small changes could amplify, potentially leading to the formation of a tornado in a place as far away as Texas. This is not to say that every butterfly's flight leads to a storm, or that every storm is caused by a butterfly. Rather, it's an illustrative metaphor for how sensitive and interconnected complex systems can be. And it's not just about weather. The butterfly effect applies to numerous aspects of life, from ecosystems to economies, where minor changes can lead to unforeseen, significant outcomes. The butterfly effect challenges our perception of causality and predictability, reminding us that the world is not as straightforward as cause and effect. It underscores the intricate web of interconnectedness that forms our reality, where minor actions can ripple outwards, creating waves of change that are hard to predict or control. The butterfly effect, a testament to the interconnectedness of all things. What would you feel if you saw our Earth from space? Imagine the awe-inspiring sight of our blue marble floating in the vast expanse of the universe. This is the crux of the overview effect, a psychological shift experienced by astronauts when they behold Earth from the cosmic perspective. The term was first coined by author Frank White in 1987. It refers to a profound cognitive shift in awareness reported by some astronauts and cosmonauts during spaceflight, often while viewing the Earth from orbit. It's a moment of clarity and understanding, a realization that our home is a tiny oasis in the unfathomable expanse of the cosmos. Astronauts have described it as a profound sense of connection, an overwhelming surge of empathy, and a newfound appreciation for the delicate balance of life on our planet. It's a stark reminder of how interconnected we all are on this small blue dot, and how our actions can impact the entire Earth. The overview effect isn't just about seeing Earth from a different viewpoint. It's a transformative experience that can alter one's perspective on life and our place in the universe. Astronauts return from space with a renewed sense of responsibility for taking care of our planet and a commitment to making it better. This profound experience has even inspired the creation of the Overview Institute, an organization dedicated to studying the overview effect and finding ways to make this transformative experience accessible to more people. Their goal is to use virtual and augmented reality technology to bring this perspective to everyone, fostering a sense of global unity and shared responsibility. So the next time you gaze up at the night sky, try to envision what it would be like to see Earth from that vantage point, to see the fragility of our planet, the unity of our species, and comprehend the vastness of the cosmos. It's a perspective that more of us should strive to understand. The overview effect, experiencing our planet's fragility and unity from the vastness of space. With the vastness of the universe, why haven't we encountered intelligent alien life? This is the conundrum at the heart of the Fermi Paradox, named after physicist Enrico Fermi. It's a question that has puzzled scientists and researchers for decades, and it continues to do so today. The paradox is built on two seemingly contradictory facts. The first is the sheer scale of the universe. With an estimated 2 trillion galaxies, each potentially teeming with billions of stars and their orbiting planets, the statistical probability of the existence of intelligent extraterrestrial life seems high. And yet the second fact is that we have not detected any signs of such life. No signals, no spacecraft, no evidence whatsoever. Hence the paradox. There are numerous hypotheses that attempt to resolve this paradox. One is the Great Filter theory, which suggests that at some point in the development of intelligent life, there is an insurmountable hurdle or catastrophe that prevents civilizations from communicating or traveling across the cosmos. Another hypothesis is the zoo hypothesis, which posits that advanced extraterrestrial civilizations are aware of us but choose not to interfere, much like zookeepers with animals. Still, others propose that our methods of searching for extraterrestrial intelligence are flawed or insufficient. We might be looking in the wrong way, or in the wrong places, or at the wrong times. Despite all these theories, the Fermi Paradox continues to stand as a profound mystery. It challenges our understanding of the universe and our place within it. It forces us to question our assumptions about life, intelligence, and civilization, and it serves as a humbling reminder of just how much we have yet to discover about the universe. So we continue our search, peering into the cosmic void with our telescopes, listening for signals with our radios, and pondering the possibilities with our minds. The Fermi Paradox, a question that challenges our place in the cosmos. Is there a mathematical ratio that governs the beauty in art, architecture, and nature? Well, some believe there is, and it's called the golden ratio. This ratio, approximately equal to 1.618, has mystified mathematicians, artists, and architects for centuries. It's an irrational mathematical constant that goes on forever without repeating, much like pi. But why do we find this ratio so enchanting? It's been suggested that the golden ratio holds a certain aesthetic appeal. When we see it in art or architecture, even without knowing it, we are instinctively drawn to it. It's as if our brains are hardwired to appreciate this particular balance and proportion. Let's take a look at some instances where the golden ratio makes an appearance. In the realm of art, the Mona Lisa, painted by Leonardo da Vinci, is one famous example. It's said that the composition of the painting adheres to the golden ratio, with key dimensions and placements aligning with this special number. In the world of architecture, the Parthenon in Greece is another notable example. The dimensions of this ancient structure seemingly adhere to the golden ratio, giving it an undeniable elegance and balance. Yet the golden ratio isn't confined to the works of humans. It's also found in the natural world. The arrangement of seeds in a sunflower, for instance, follows the golden ratio. The seeds grow in spirals that allow for the maximum amount of seeds in the smallest amount of space, and the number of left and right spirals are consecutive Fibonacci numbers, a sequence intimately connected with the golden ratio. So, the golden ratio appears to be everywhere, from the canvas of a master artist to the heart of a sunflower. It's a fascinating concept that bridges the gap between mathematics and aesthetics, between human creation and natural phenomena. The golden ratio, a mathematical constant shaping the beauty around us.